Hello, today I am going to talk about a very interesting topic of fluid dynamics. It's called D-level nozzle. So our topic is D-level nozzle. D-level nozzle. So the problem is very simple. It is the simplest flow in one dimension with varying cross section. So let us consider a one dimensional flow where the cross sectional area AX is very small. So you can consider it as a one dimensional flow. So now one dimensional flow through a pipe. Now throughout the pipe mass is conserved. So we can say that we can take like 2 points. So the cross sectional area, it is not constant, it is actually varying. It has a slow variation with x. So uh, we can take 2 points. This is the point 1 and this is point 2, and we can say mass is conserved throughout the pipe. So the mass flowing here is equal to mass flowing there. So we can write this equation, rho x Vx Ax, which is the mass flowing per unit time from this side, which will be equal to, from one point, this will be equal to rho 2x V2x A2x, or we can say rho x Vx Ax is equal to constant. Now we can take the derivative with respect to x of this equation. So you can get 1 by rho x d rho x dx plus 1 by vx dvx dx plus 1 by ax dax dx equal to 0. This is our mass. This is from mass conservation through the 5. Now we can write the Euler equation in one dimension as following: v dv dx, this is in one dimension, equal to minus 1 by rho dp dx, where dp dx is the pressure gradient in the flow. Now we have the relation between p and rho, p equal to k rho power gamma. So p equal to Cs square rho power gamma. Sorry, p equal to Cs square rho. Cs is the sound speed in the medium. So you can write this equation as minus Cs square by rho d rho dx. So from here we can calculate d rho dx is equal to minus rho v by Cs square dv dx. Now put this d rho dx in equation number 1. So substitute this d rho dx from here. So you can get 1 by rho d rho dx is rho v by Cs square dv dx with a minus sign plus 1 by v dv dx plus 1 by a dA dx equal to 0. Now we can take common here dv dx. So let's take 1 by v dv dx outside. So inside it will be, from this part it is coming 1 minus, so 1 by v dv dx, rho cancelled, so v square by Cs square. So define Mach number as v by Cs, so this becomes m square plus 1 by a dA dx equal to 0. So in this equation a and v are the functions of x. Now we will see a very interesting thing. First one is, if the flow is subsonic, m less than 1. Subsonic speed means the speed is less than the sound crossing speed. So if m less than 1, then we have dv dx. So m is less than 1, so this part is positive. So you can see, say dv dx and dA dx has opposite sign. Opposite sign. So what we can say is that if we increase Vx, let's say in the other way around, if we increase Ax, our velocity will decrease. I mean, our pipe is there. If we increase the cross sectional area, the velocity will decrease. And if we decrease the cross sectional area, velocity will increase. And this is very intuitive. The smaller the pipe, smaller the cross section, larger the velocity. This is actually very intuitive result, and this is for this intuitive argument is from subsonic case. Subsonic case means Mach number is less than 1. Now the interesting thing is that if Mach number is greater than 1, if Mach number is greater than 1, we can say from this equation that dv dx and dA dx has same sign. Mach number greater than 1, so this is negative, and this is positive. So if we write dA dx and dv dx in the two sides of the equal, we can say that this has same sign. So what does this mean? This means that if we increase Ax, if we make the larger cross section of the pipe, our velocity will increase. So smaller the cross section, now we increase the cross section, velocity will increase. This is the counterintuitive result, and this counterintuitive result comes from supersonic case. Supersonic case. Now think of a nozzle like this kind of a pipe where the cross section is varying. So here you have subsonic flow. So this flow is converging subsonic flow. Converging subsonic flow, and for subsonic flow Mach number is less than 1. So if Mach number is less than 1, you decrease the cross sectional area is decreasing, the speed is increasing, and make the arrangement such that the speed here becomes cs, the speed here becomes cs. So in this point v equal to cs, and here that means Mach number equal to 0 in this region. So here the variation of Ax is 0. You can see from this equation, if Mach number is 0, then dA dx will be 0. So here if you have a flat region, so you make the arrangement where you are giving subsonic flow, you are narrowing the cross section and make v equal to cx in some position where the dA dx is 0. So here you reach the velocity v equal to cs. Now if we further increase the cross section, what will happen? This side is m greater than 1, Mach number greater than 1. So you are increasing cross section, and as a result your flow velocity will increase. So you are increasing cross section means flow velocity will increase. So this is the supersonic flow. So this is diverging supersonic. So if you keep increasing the cross section of the pipe, the flow speed will increasing largely. So that's why it is called diverging supersonic. So this is a nozzle where you give a subsonic flow and make it supersonic flow, and this type of nozzle is called D-Laval nozzle. D-Laval nozzle. Thank you.